So, in the last class we talk about conductors, we talk about the basic property of conductor. Electric field inside conductor is 0, there will not be any charge residing on inner or inside the conductor. All the extra charge or excess charge what you have given, that will appear on the surface of conductor. Whole conductor will be at the same potential, equipotential body, right. So, today we will talk more about conductor and then we will start our next topic, capacitor, right. So, today we will talk about earthing first and then we will talk about capacitor, right. What is earthing? So, when you connect a conductor to earth, that process is called earthing, right. So, when you connect a conductor to earth and there can be easily exchange of charge particle between conductor and earth, that process is called earthing. Earth we visualize as a very big conductor whose potential is 0. So, visualize a situation where you have one conductor and you have connected it to earth which has got potential 0 and conductor had some charge. So, when you connect these two, charge keep flowing till the potential on conductor also become 0. So, as there will be movement of charge particle, as earth is very big, flow of some charge will not make any change in the potential of earth. So, earth will remain at 0 potential while our conductor will come from higher potential to 0 potential or from some lower potential or negative potential to 0 potential. Till then there will be exchange of charge particles. So, charge may come from earth to the conductor or charge may go from conductor to the earth. The condition is the potential of conductor will finally become 0, right. So, this is a symbolic representation of earthing, right. So, we connect any conductor to earth, this is the way we represent earthing. So, what we have just discussed, earthing, earth is a huge conductor and its potential is assumed to be 0. The potential of earth is not affected practically by addition or withdrawal of some charges because it is very big. So, its potential is not going to change by exchange of the charge particle from conductor to earth. Hence, whenever a conductor is connected to earth, the charge flow between conductor and earth in such a way so that the final potential of conductor becomes 0. So, ultimately what we need to do, we have to make potential of conductor 0, right. So, let us take one simple example so that you will understand what earthing is. So, here I have got one point charge which is kept right in front of a spherical conductor which is connected to earth. So, initially there was no charge on spherical conductor. When you connect it to earth, earth may give some charge. So, I do not know how much charge is given by earth, let the charge given by earth is q. So, if there is no charge here, assume body is having some charge, it will be uniformly distributed on the body so that it will make electric field 0, but here there is charge. So, what will happen, this distribution whatever we are getting, what additional comes and there will be redistribution. So, altogether on the surface I can draw this charge and induce charge this way, right. So, this will attract all the electron or try to attract electron, the process will take place till the electric field inside the conductor becomes 0. We have seen similar problem before, right. So, all the electron will get attracted here, right, or try to start drifting in this direction, there will be excess and there will be deficiency. So, something like this will happen. So, when you add this and this, total charge will be q, right. So, there will be effect of induction as well as what it got from earth, right. So, this charge plus whatever be the induced, right, they will be there on the surface of conductor. Now the question is find the charge on the conductor. So induction is just a redistribution and there was no initial charge on the conductor, so net induced charge is 0, but effect of induced charge will be there. So net induced charge will be 0, but the effect will be there at every point. So I want to find out this, how much charge that appears on conductor, right. So as it is connected to earth, and you can see this charge is producing potential at every point, and the final potential has to be 0. To make final potential 0, earth has given some charge. I do not know whether charge is given by earth or charge is given to earth. So I just assume charge is given by earth. If charge is given to earth, automatically this will come with negative sign, right. But the main concept is the process of flow of charge will stop when the potential of conductor will become 0. So potential of conductor has to be 0 when electrostatic condition is achieved. I can write the potential at any point inside the conductor because of this q charge. Only thing I require is the distance. But the problem is the potential created by the induced charge will be difficult to calculate for any other point, but if I take this point, because of this potential at this point I can easily write, because of induced charge potential at this point I can easily write, and because of this charge I can easily write the potential at this point. So I have selected point here, and we know that as there is no net electric field inside the conductor, potential at every point will remain same. So potential on the surface of conductor or any point inside has to be 0. So let us take this point. So every point will have 0 potential, this point will also have potential 0. I can write potential there kq divided by d plus potential due to induced charge, whatever charge got induced, because of that what will be the potential at center. So charge, every element is at same distance, directly divide by r, I can write potential. Now what earth gave, that kq divided by r, that will also appear on the surface, excess charge appears on the surface of conductor. So every charge particle will be at distance r from the center, I can write potential at center due to that charge kq divided by r. This has to be 0, right. So I need to simplify this one. Now this q, whatever be the minus coming, same amount of plus will come, then this additional charge q came. So induced charge effect will get cancelled out at the center. If only induced charge I take into account, minus and plus, forget about this charge for time being, assume that this charge is not there, only induced charges are there. Whatever negative charge we have, same positive charge we will be having, this negative will produce negative potential and positive will produce positive potential. So the net potential produced by this induced charge has to be 0, right. So from this equation what we are getting, this small q, this kk gets cancelled out, and then minus capital Q r by d. So this is the charge given by earth, minus sign indicate that this will give charge to the earth, right. If I ask how much is the charge given by conductor to earth, plus of this, how much charge appear on the surface net, how much net charge appear on the surface, that is minus q r by d, right. I hope this example is clear. Let us see another example. So, same example, now here I have connected inner one and the outer one to earth, and question is find the charge on the innermost and outermost shell. What we have done, inner one is not having any charge initially, outer one is not having any charge initially, middle one, you can see middle one carries capital Q charge, right. So, I will assume that this earth gives Q dash charge to inner one and Q double dash charge to outer one, right. So, there are two unknown, I require two equation, and you can see that if I can write potential here and make it 0, I can make one equation, and similarly if I write the potential at outer one and equate it to 0, I can make second equation. Now, I have got two equations that I can simplify and I will get the value of Q dash and Q double dash, right. So, this is the approach. Let us see how to write the equation. So, for innermost, potential at innermost is to be 0, right. So, innermost will have potential because of its own charge, that I can write k q dash divided by a, and we know because of charge distributed on the surface of spherical shell, potential at every point inside remains same whatever be the potential on the surface. So, potential on the surface because of that capital Q is, right. Now, because of the outermost potential at innermost, because of outermost charge, what is the potential at innermost, divide by 3a is equal to 0, right. This I can simplify, k will get cancelled out, a also gets cancelled out. If I multiply the whole equation by 6, then what I can see is 6q dash here, this will be plus 2q dash q double dash, and this I will bring on other side, that is minus 3q. This is our first equation, right. So, two unknowns are there, first equation we already made. Second equation, as outer one is also connected to earth, we have to make potential 0. So, now potential outermost is to be 0 because it is connected to earth. So, for charge inside, potential outside, formula is kq divided by small r. So, you can assume that whole charge is concentrated at center and from there at distance 3r. Similarly, due to middle one, you can assume that charge is concentrated at center and from there at distance 3r, right. So, k q dash on outermost potential due to all the charges 3a plus kq divided by 3a plus kq double dash divided by 3a is equal to 0, right. If you simplify this equation, then you can see that you are getting q dash plus q double dash is equal to minus q, right. All three will go on other side. So, now you can simplify this equation and this equation. So, if I multiply this equation to 2 and subtract, I can solve, right. Let us see. So, this equation I am writing 2q dash plus 2q double dash is equal to minus 2 capital Q. I multiplied 2 to this equation, this one is here. Now, this one, as it is 6q double q dash plus 2q double dash is equal to minus 3q. If I subtract these two, you can see if I subtract these two, minus minus plus, these two get cancelled out, and here I can see minus 4 q dash is equal to, this side I see q, that means q dash is equal to capital Q by 4 with minus sign. So earth will give minus q by 4, or I can say this will give to earth plus q by 4, right. Here minus sign indicate that the direction of flow is reverse what we have taken, direction of flow of charge is reverse what we have taken. So capital Q by 4 will be given by innermost to earth. Same way I can find out q double dash. So you have the value of q dash, look at this equation. So you have the value of q dash, that is capital Q by 4 plus q double dash is equal to q, and get this term on other side, what we can see is q double dash, this is minus, right, this is minus, so this is minus q plus q by 4 will give me minus 3 q by 4. So similarly here again minus sign is appearing, that means instead of earth giving charge to the conductor, charge will be given by conductor to earth, and the magnitude of that charge will be 3 q by 4. I hope example is clear. Earthing means making potential 0, making potential 0, making potential 0, right. Let us see one more example. So if I give this one, say plus 10 microcoulomb and this as minus 10 microcoulomb, right, and initially switch was open, right. So this one initially will give you distribution like 0, 10 q minus 10 microcoulomb and 0 this side, right. So even if it is open or close, it does not make any difference, charge will always appear on the inner surface, and charge, there won't be any charge appearing on the outer surface, right. What I am saying is, assume that earthing is not there, there is no earthing here, right, and if I give 10 to this one, no earthing. Let us first discuss no earthing. If there is no earthing, this is given 10 microcoulomb charge and this is given 0, right. We know from our formula what we have discussed for two plate system that charge appearing here is q1 plus q2 by 2. So 5 microcoulomb will come, q1 plus q2 by 2, right, and this side again q1 plus q2 by 2 minus 5 microcoulomb. Inside this charge has to be, as total charge is 10, so the remaining charge will appear here 5 microcoulomb, and the charge coming here is minus 5 microcoulomb, right. If no earthing is there, first I am discussing no earthing, then I will talk about earthing, right, so that everything will get clear. So this would have been the situation if earthing is not there. Look at this one, plus and minus, so field lines will be from positive to negative, it will be this way, right. Here this is positive, field lines here will be like this, right, and on this side similarly, as this is positive, field lines will be like this when earthing is not there. So when earthing is not there, then this is the situation. So 10, 5, 5, 0, this side minus 5, this side plus 5, you add, conservation of charge is still valid, charge is 0. Now if I earth this, if I connect it to earth, look at the arrangement. If I connect this to earth, the potential here has to be 0, right, and the potential as you keep going till infinity, as there is no charge between this plate and infinity, there should not be, as there is no charge between this plate and infinity, the potential from here which is 0 and infinity which will again 0, for that to happen there should not be any charge. As we do not have charge, the potential here 0 and infinity 0, that can be possible only when field lines are not there. If there is charge here, assume there is some point charge, so it might be possible that potential first increases and then decreases to 0, because here 0, infinity 0. If I have negative charge, then there might be possibility that potential this plate 0 and then potential decreases, it become negative, then again it becomes 0, right. But we are not keeping any charge, so only possibility left that throughout this region potential remains same, 0 0 0 everywhere. If potential remains same throughout the region, then electric field in this region has to be 0. I hope you are understanding what I am saying. As there is no charge particle in this region, potential here 0, infinity 0, then there is the only possibility that can be 0 when field here is 0. And we have seen that the field on outside the conductor or outside the arrangement, right, here and here, field depends on this charge and this charge appearing on these surfaces. In the last class we have discussed. So field here can be 0 only if these charges are 0. That means there should not be any charge appearing on outer surfaces if it is connected to earth. So when we are connecting it to earth, one thing is sure, that charge on the outer surface of this arrangement has to be 0. If it is 0 this side, it has to be 0 this side, because these two charges must be same. As it is isolated, the whole 10 microcoulomb charge will appear on the inner surface. If this is 10 microcoulomb charge, facing surface will get minus 10 microcoulomb charge, and we already got this value 0. Initially this was not having any charge. Now I am talking about when it is earth, one of the plate is earth, right. So I will erase all. I hope you understood logic. There should not be any field outside the conductor if it is earth. So once earthing is done, immediately the field outside this side will become 0. Field this side has to be 0, and for this field to be 0, we have seen these charges are responsible. The charge appearing on the surface are responsible to produce this field. So to have field 0, there should not be any charge on the outer surfaces. So we will start with the plate which is not connected to the earth. Start with the plate which is not connected to the earth. This side charge is 0, it is not connected to anything else, total charge has to be conserved, so 10 microcoulomb charge will come on inner surface. And the facing one will get minus 10 microcoulomb charge. From Gauss law we have minus 10 microcoulomb charge. This was not having any charge initially. So if this plate was not having initially any charge and it is connected to earth, that means earth must have given minus 10 microcoulomb charge, and whatever earth is giving, that will appear on the inner surface. Outer surface again charge will remain 0, right. So for spherical conductor we can easily calculate the potential. We will calculate the potential and we will make the potential 0. But in infinite sheet we cannot calculate the potential, we can calculate the potential difference. So, by logic I got that on the outer surfaces the charge has to be 0 to make field in this region and in this region 0. So, what will happen, earlier you must have seen that field was like this, right, field was something like this. As soon as you connect it to earth, this one or this one, any of the plate, any of the surface, it is not ki earthing is done this way, earthing can be done this way also, right. Any of the surfaces you connect to earth, immediately this side and this side field will become 0, field will be there only this side. Right. So, in this region there will be field, there will not be any field this side and there will not be any field this side. So, this situation when I connect it to earth, immediately here field will become 0, earth will deliver some charge or earth may extract some charge in such a way, so that this side and this side field becomes 0. To have that condition, charges appearing on the outer surfaces of this system must be 0, there will be only field in this region, right. So, we have discussed one example based on, one more example based on earthing of plates, okay. Let us see one more example, spherical one. So, outer one was having charge 3q and inner one is having charge minus q, and then we connect inner one to earth. Let the final charge appearing, no matter what earth gives, let the final charge appears is x on the inner one, and as outer one is isolated, its charge will remain 3q. I am asking what would be the charge, how much charge will be flown into earth, how much charge is flown into earth. So, the difference what you have assumed and this one, the difference will flow into the earth. Let us write the equation. So, inner one potential has to be 0, I have to write potential on inner one and equate it to 0. So, because of its own charge it will be k x divided by r plus, because of this charge k 3q divided by 2r, and if that becomes 0, this is r, right. So, you can see this r will get cancelled out, kk will get cancelled out, the value of x we are getting, 3q by 2. So, x is minus 3q by 2, this will be the final charge on inner conductor, right. So, if x is minus 3q by 2 and it was minus q, that means q by 2 further flows out, already it is minus q and finally it become minus 3q by 2. That means from this extra q by 2 will flow out, then it will become minus 3q by 2. So, how much charge is given to the earth, that is q by 2. Concept is potential is equal to 0. So, this is what I was saying, for spherical one, so you can easily calculate potential, as you can calculate potential you can equate it to 0, but if there are infinite sheets we cannot make the potential 0 by calculating it. So, there we use logic, right, ki what would be the charge distribution on the outer surfaces. So, no matter how many plates are there, if any of the plate is connected to earth, the outermost surfaces will always have 0 charges. So, there will not be any charge on the outermost surfaces, right. So, I hope this whole concept of earthing is clear, right. Let us discuss one more concept, that is called electrostatic pressure. What is electrostatic pressure? If I give Q charge to this conductor, right, and I take a small part on the surface, So, field at this particular point will be in this direction and the value is sigma upon epsilon naught, we have calculated there, right. So, the net field at that particular point is sigma upon epsilon naught, right. If I ask how much is the force experienced, this is just outside this element, how much is the force experienced by this element? Because once I have force, divide by area, I will get the pressure, right. That pressure is coming because of the electric force experienced by the element. But this is the total field or net field? Just outside, net field just outside, right. So, if I divide this whole thing in two parts, one this patch and the remaining one. So, net is because of this patch, let us call it E dash, and because of the remaining part, let field is E double dash. Both will create field in the same direction. E dash plus E double dash will be sigma upon epsilon naught, right. So, outside E dash and E double dash both will be in same direction. This small charge element, what it is producing E dash, and what the remaining one is producing here, that is E double dash, they are coming in same direction. When you add, you will get sigma upon epsilon naught. This sigma upon epsilon naught result we have already derived. Now, when I go just inside, the field inside has to be 0. For field inside has to be 0, that means this element is cancelling the effect of whatever be the remaining distribution at this particular point. So, this element will produce field in this direction, that is E dash, just inside, just outside. Look at the element, very small part. So, whatever it produces this side, same magnitude it will produce on other side. If I consider charge positive, this side it will create field opposite to the distribution or away from the distribution, and this side it will create field away from the distribution, right. So, because of the element, if I go this side, field will be in this direction. Because of the element, if I go this side, field will be in this direction. They will cancel each other, right. Field will be in this direction and this side it will be in this direction. Now, what I am saying is this and this must get cancelled inside. So, this is producing field E double dash here, right, E double dash. So, just inside these two must cancel each other. To cancel each other, their magnitude has to be same. So, for inside to be 0, their magnitude must be same. So, from inside I can conclude that E dash must be equal to E double dash. If E dash is equal to E double dash, this we have concluded from if I substitute that in this expression, if I substitute this one in this expression, then I will get E dash is equal to E double dash, E dash is equal to E double dash, that means E dash is equal to sigma upon 2 epsilon naught. So from here I am getting E dash is equal to sigma upon 2 epsilon naught, and I am getting E double dash is also sigma upon 2 epsilon naught. Right. To get force, now this small element is kept inside the field created by the leftover part. Field created by leftover part is E double dash. In E double dash field, this charge is kept, let us call it dq dash. So charge on this one, let us call it dq dash, right. So if I ask how much is the force on this element, so charge on the element into field, it is kept inside. So it is kept in E double dash field, this will be the force. How much is dq dash? Sigma into area. So surface charge density into area of element, let us call it d area, area of element. So sigma is equal to charge per unit area, this I am using, and the field sigma upon 2 epsilon naught, sigma upon 2 epsilon naught, this is df, right. Now df by dA is pressure, pressure is given by df by dA. So divide by A, you can see what we are getting, sigma square divided by 2 epsilon naught. So this is the electrostatic pressure at every point on the surface. So on a small element, the remaining charge will have field, as this small element is kept in the field of the remaining charge, it will experience force. That force per unit area, force is perpendicular to this area, force per unit area will give you pressure. That pressure is electrostatic pressure, right. So we will talk about this one later after discussing the distribution in capacitor, but for time being just keep this formula in mind, that sigma square upon 2 epsilon naught is the electrostatic pressure, right. So our conductor is over, now we will start capacitor, right, using all the concept what we have learned in conductor. So that is why I have covered conductor first, so that you can easily understand capacitor, right. What are capacitors? Capacitors are energy storing device which stores energy in the form of electric field. So in circuit you must have seen these type of cylindrical things, those are capacitor. Separately you can see this type of structure you will get for capacitor. So there are other designs also, but one of the design I am showing you, right. So this device stores energy in the form of electric field. So capacitors are the devices which store energy or electrical energy in the form of electric field. How they store energy we will see in this chapter. Now to measure how much energy it can store or how much charge it can store, I need to have a parameter which can give me idea whether the charge storing capacity of capacitor is more or less. So for that I define parameter associated with capacitor as capacitance. So capacitance is the ability of capacitance is the measure of ability of capacitor to store charge or store energy. Larger the capacitance, higher would be its ability to store charge in it, right. So, first definition of capacitance. Capacitance of a conductor is the measure of its charge storing capacity, right. So, if I take a conductor, capacitor is the property associated with conductors only. So, I need to have conductor. So, I have taken one conductor. If I give Q charge to the conductor, that will get distributed. How it will get distributed? We have already seen responsibility of this charge is to make electric field inside the conductor 0. So, it will get distributed like this. So, depending on the shape, distribution can be uniform, it can be non-uniform, right. So, in conductor we have learned that as the field at every point inside is 0, the potential at every point must be same. So, the potential here is constant, potential what you are going to get, that will be a constant, at every point it will be same. So, everywhere it will be same, right. Here meaning of this constant is that every point it will be same. You change the distribution, you give more charge, potential will get altered, right. There will be new potential. For example, you are giving Q, potential everywhere we are getting 2 volt. You just increase to some Q dash, potential everywhere will become 4 volt. Similarly, you further change the charge, potential everywhere will become 8 volt, right. So, depending on what we have given, we will get potential, right. So, I can say potential of the conductor is directly proportional to charge what it receives. Potential of conductor is directly proportional to charge it receives. For example, if I take a spherical one, it is easy to conclude from here. I give Q charge. So, that Q charge will be uniformly distributed over this conductor, and I can directly write potential is equal to KQ divided by R. R is the radius of conductor which is constant, this case constant, that means potential is directly proportional to charge what we have given. So, what potential that will appear over conductor, that will be proportional to what charge we have given to conductor, right. So, depending on this charge, you will get the potential on conductor. I can say Q is proportional to V or V is proportional to Q. If I remove this proportionality sign, then I will write Q is equal to some proportionality constant into V. This proportionality constant is called capacitance. This proportionality constant is called capacitance. So, C is the capacitance of this conductor. So, ability of conductor to store charge is measured by parameter called capacitance. It is a proportionality constant. When you are writing equation Q or you are writing relation between charge and the potential, then whatever proportionality constant that comes here, that is the capacitance of this arrangement. This is the way it is defined, right. So, the proportionality constant C is called the capacitance of the conductor, and SI unit of capacitance is Coulomb per volt. You can see from here I can write C is equal to Q by V. So, this is Coulomb per volt, and it is also called as farad. So, capacitance will be given in SI unit farad. 1 farad capacitor, 2 farad capacitor, 3 farad capacitor. As the value of 1 farad, 2 farad is very large, generally the type of capacitor we will be having or we will be using in circuit, they will be of microfarad range. So, 1 microfarad, 2 microfarad, that range they will be, right. So, maximum time you will be getting the capacitance in micro or millifarad range instead of getting capacitance in farad range, right. But this is SI unit of measuring the parameter called capacitance, clear. So, previous case I had only one conductor which I gave charge Q, and that Q was uniformly distributed. You can see this one, right. Now, in order to have larger capacitance, what I can do, I can bring two capacitors which are oppositely charged near. So, I give Q charge to this one and minus Q charge to this one. Now, this arrangement will give me more capacitance as compared to the arrangement I had earlier, right. So, now in order to have larger capacitance, I can have two conductors which are kept at some finite distance this way. So, in this case charge will be proportional to potential difference. So, as this is positively charged, the potential on this one will be something positive, and this is negatively charged, the potential appearing on this whole conductor will be something negative. Here potential difference, we are talking about the difference, potential difference will be V plus minus V minus. So, charge what you give to this arrangement, that is proportional to the potential difference. When I talk about the charge on the capacitor, we talk about the charge on positive potential conductor, right. So, this I will say as charge on capacitor. So, this is charge on capacitor. Because net charge, if you look at, net charge is 0, plus and minus, right. So, this is the common terminology used. Whatever be the charge on the positive plate, that is considered as charge on the capacitor, right. So, charge on capacitor is Q, and depending on that there will be potential difference, and I can write potential difference here or whole expression as Q is equal to proportionality constant, that is nothing but capacitance of the arrangement C V plus minus V minus. So, capacitance I can write Q divided by V plus minus V minus, right. So, we will take two conductors and placed at finite distance, and we will calculate the capacitance of the arrangement like what we have done here. And the value of this capacitance will depend on the shape and size of these conductor. So, what it all depends on, capacitance depends on shape, size and the geometrical placing of the conductors forming capacitor. So, depending on the separation, depending on the shape and size, you are going to get the value of C. So, the value of C depends on these parameters that we will see, right, while deriving the formula. But for time being, I am just giving you what C depends on. What C is we discussed in the previous slide. Now I am telling what C or on what factors this C depends on. And the capacitance also depends on the medium in between. So, if you place any other insulating medium, for example, I place some wooden plank here instead of air, this capacitance will get alter, right. So, any dielectric medium I place here, this capacitance will get alter. So, capacitance depends on these factor, and capacitance also depends on what is the medium in between these two conductors, right. So, now let us see, we will take different system and try to calculate the capacitance associated with the arrangement. So, there are parallel plate capacitor, cylindrical capacitor, spherical capacitor, these capacitor we will calculate capacitance, right. So, let us start with parallel plate capacitor. What is parallel plate capacitor? Two plates we are placing at some finite distance. So, say this distance is d and the face area of the plate is A. So, area is A, right, area as A. I am giving q charge to this and minus q charge to other one, right. So, here I will add charge. So, plus q I gave to this plate and minus q is given to this plate. If I ask how much charge will appear on this side, so if q1 is given to this plate and q2 is given to this plate, charge appearing on this side will be q1 plus q2 by 2, and charge coming this side will be q1 minus q2 by 2, and charge coming here will be negative of q1 minus q2 by 2, and here again q1 plus q2 by 2. Last class we have seen the distribution. So, q1 plus q2 by 2, if you add these two, q1 plus q2 by 2, you will get 0 here. This plus this by 2 will give you 0. Inside q1 minus q2 by 2, q1 minus q2 by 2, that will be the charge appearing on the inner surface, that is coming q. In front of this equal amount of negative charge. So, this I can say this whole charge will come here and this charge will come here. On outer surfaces there will not be any charge. So, this is the arrangement, right, and I want to find out the capacitance of this arrangement. So, to calculate capacitance, steps are: get the potential difference, charge by potential difference will give you capacitance, right, charge by potential difference will give you capacitance. So, I require to calculate capacitance, charge divided by potential difference, V plus minus V minus, right, this is what I need. So, charge is appearing only on the inner wall of the arrangement. So, in 3 dimension if you want to look, see this one. So, this negative charge, this is the negative charge minus q, and positive charges will be on other face, not this face, on other face. So, this inner face, this will be plus q, right. If we want to calculate potential difference, we know that potential difference is dV is equal to E dot dr with minus sign. So, using this one I can get potential difference, by that I can find out capacitance of the arrangement, right. Now, field inside capacitor, field pattern inside capacitor. So, as this one is positive, this one is negative, and field here depends on these charges only. Because of this positive, field will be in this direction, because of this negative, field will be in this direction. Field at this point depends on the area. This area is A. This area is area I am considering A. Now, if this area is A and I ask what is the field at this particular point due to this negative distribution, negative charge distribution, it will be in this direction, and the value is Q divided by 2A epsilon naught. I hope now in diagram it is clear. Similarly, because of this positive charge, field will be away from distribution, and field will be away from distribution, and the value will be Q upon 2A epsilon naught. So, the net field at this particular point, will be Q upon A epsilon naught. So, this field is Q upon A epsilon naught. You can see that this whole thing is constant. It is independent of the distance from the plate, because plate is very large. From plate at distance 2 centimeter or 3 centimeter, everywhere field will be same. So, if because this field is same, I can take this out and I need to integrate dr, how much distance you are covering when you are moving from positive plate to negative plate. So, V plus to V minus 0 to d, this is plus, I am writing it here plus, and this is V minus, and I am starting from here and I am going by distance d, right. So, when I am at positive plate, this r is 0. When I reach to negative plate, potential become V minus, and this gap become d, this r become d. If you simplify this side, minus, take minus on other side, right, minus I am taking this side. So, V minus minus V plus and then minus will make it V plus minus V minus is equal to integration of dr 0 to d will give you d. So, if I substitute this value here, I will get the capacitance. So, no matter whatever be the situation, this is the step we have to take to get to the capacitance. Try finding potential difference. In some cases you can directly get the potential difference, like in the case of sphere you can directly get the potential difference. If you are unable to directly calculate the potential difference, then we can take help of field to get the potential difference, and substituting that potential difference here, I will get the capacitance. So, Q divided by V plus minus V minus, that is Q divided by Q into D divided by A epsilon naught, right. So, capacitance is A epsilon naught by D. So, capacitance of two plate system or parallel plate capacitor is given by formula C is equal to A epsilon naught by D, where D is the separation between plates A is the surface area of the plate, you can see that capacitance depends on separation as well as area. If I keep area fixed, if I keep this area fixed and increase separation, if I move these two plates apart, as D increases, capacitance decreases. So, I am bringing two capacitor closer, the capacitance of the arrangement will be more as compared to when they were at larger distance. So, two conductors at lesser separation will have more capacitance as compared to when they were at large separation, right. So, I hope procedure is clear. You have to always keep in mind capacitance is charge divided by potential difference, and this is the charge on capacitor. Charge on capacitor is always charge on positive plate of the capacitor. So, this plus Q is called charge on the capacitor that is needed to be substituted here. So, substitute here, divide by the potential difference, you will get capacitance. So, whether we have parallel plate capacitor, spherical capacitor, cylindrical capacitor, everywhere we will follow the same procedure, right, or any new situation if you get, in that also you follow the same procedure to get capacitance, right. So, I will erase all this. I hope everything is clear. You can see field pattern also. So, this side we have positive charge and here we have negative charge. From positive to negative, so capacitor is storing energy in the form of electric field. So, between two plates there will be field in a space and capacitor is storing energy in the form of electric field, or I can say capacitor is storing charge. Net charge is always 0, right. So, whatever charge appearing on the positive plate, that we considered as charge on capacitor, right. So, I clear all the thing, separately I write epsilon naught A by D is the capacitance, this is Q, this one is minus Q, plus will appear on this face, minus will appear on this face, and in this region there will be field. As there is no charge on the outer surfaces, there will not be any field, right. So, it depends on the dimension, it depends on the area of the plate. Larger the area of the surface area of the plate, larger will be the capacitance. So, you have taken larger plates, you will get more capacitance as compared to when you take a smaller plate. So, larger the area, larger will be the capacitance. Larger the separation, smaller will be the capacitance. If you increase the separation, capacitance will get decrease. If you decrease the separation, capacitance will get increase, right. So, parallel plate is over. Let us see another one. Isolated spherical conductor. So, we have got a spherical conductor and we want to find out the capacitance of this arrangement. So, procedure is I will give charge Q. Here the second one I will assume to be placed at infinity, right. So, second one, because lines, if you give charge, the field pattern will be something like this. As field pattern is something like this, you can say that lines are going till infinity. If lines are going till infinity, I can assume that this is first conductor and the second is placed at infinity, right. And what is the capacitance? So, capacitance of the arrangement is charge what you give and potential difference what we get, V plus minus V minus, second one is at infinity. So, potential there will be 0, right, here I can write 0. So, I need to just write the potential of this one, potential of this one is sphere, potential of this sphere once charge q is given. So, V is equal to kq divided by r, that will be the potential of this conductor. I will substitute the value of potential here. So, what we are getting, that is q divided by kq divided by r, simplify, what we are getting, q gets cancelled out, this is r and k if I substitute 1 upon 4 pi epsilon naught, 4 pi epsilon naught will go to numerator, then 4 pi epsilon naught. So, for isolated spherical conductor we are getting capacitance 4 pi epsilon naught r. So, higher the radius of this one or larger the radius of this one, larger will be the capacitance, right. If I place the second one at some finite distance, so this one is having say radius r, another one is having radius 2r, 3r, then what would be the capacitance? To calculate that I have to again follow the same procedure. For capacitance, charge divided by potential difference, get the potential difference between two conductor, simplify, you will get capacitance. Let us see. So, spherical capacitor, okay. So, these are two spherical shells, inner one shell, outer one shell. So, two spherical concentric shell of radius r1 and r2 respectively. Now, if I give q charge to this and minus q charge to this, we will first see the distribution. If I give q charge to inner one and minus q to outer one, facing surfaces will have equal and opposite charge, from Gauss law we have. So, this surface will have minus q charge. If this surface itself is having minus q charge, that means there will not be any charge residing outside. So, on this one, outer surface will not have any charge, inner surface will have charge minus q. So, this is the way charge will get distributed, right. Now, I will erase this one, and if you look at the way we have field in a space, let us first distribute the charge. So, this plus q will be distributed uniformly over inner one, and this minus q will also get uniformly distributed, but on the inner wall of outer one, right, and outer one will not have any charge. So, let us look at the field pattern first. Plus q minus q. So, lines will start from positive charge and terminate at negative charge. Line will start from positive charge and terminate at negative charge, right. So, this is the way field lines will be there. As outer surface is not having any charge, there will not be any line here. Similarly, there won't be any line inside because inside there is no charge residing, right. So, this is the way field pattern be there in space. As you can again see that energy is stored in the form of field. So, this arrangement is storing energy in the form of field, or I can say this arrangement is storing charge. Now, we want to find out capacitance. If this is the way charge is distributed, plus I will draw it here minus q I hope you understood the logic why we do not have charge on the outer surface, whole charge will appear on the inner face. So, here minus and here plus. As for spherical body, we can easily calculate the potential difference. I can directly write potential difference, right. So, what we want is capacitance, that is q divided by V plus minus V minus, right. What is the potential of inner one, because inner one is having positive charge, it will have positive potential. What is the potential of this one? So, because of its own charge there is potential, I can write k q divided by R1 plus, because of the charge on inner wall of outer one there is potential inside, that I write k minus q divided by R2, right. Inner one is positively charged. Now, outer one which is negatively charged, that can be written kq. For outer one, because of these two charges I need to write potential, because of this charge and because of this charge. So, here I can assume this to be concentrated at center and at distance 2r or R2, that is kq by R2 plus, because of own charge, because of this minus q charge, what is the potential on the surface, that is minus q divided by R2. I need difference. So, when I find difference, these two terms will get cancelled out, right. So, V plus minus V minus, what we are getting is k q plus then minus minus, right, 1 upon R1 minus 1 upon R2. This if I substitute here and simplify, I will get the capacitance. So, let us substitute q I can see divided by kq in bracket, I can simplify R2 minus R1 into R1 R2, right, R2 minus R1 R1 R2, clear. So, q getting cancelled out, k is 1 upon 4 pi epsilon naught, 4 pi epsilon naught will go in numerator and 1 upon R1 R2 will also go in numerator, 4 pi epsilon naught R1 R2 divided by R2 minus R1, right. This is what we are getting as capacitance of this arrangement, right. Now, let us erase this part, let us erase the procedure and focus on what we got. So, C is equal to 4 pi epsilon naught R1 R2 divided by R2 minus R1. If I say this outer one is this R2 is made infinity. So, this R2 when you are making infinity, right. So, take R2 from these two. See, I can also write 4 pi epsilon naught R1 divided by R2 I am taking out, this can be written R1 divided by R2, R1 divided by R2, right. Now, if I say R2 is tending to till infinity, R2 is tending to infinity, this 1 upon R1 upon R2, this whole quantity will be tending to 0. So, when R2 is tending to infinity, this C is tending to 4 pi epsilon naught R1, 4 pi epsilon naught R1, this was the capacitance we got for isolated capacitor. That means what we are getting is correct. So, when this radius is increased to infinity, this will be at infinity, this situation will be same as the situation what we have got in previous case, where capacitance was 4 pi epsilon naught R. So, second plate I can assume, or second sphere I can assume to be infinity for isolated capacitor, right, or isolated sphere. Now, so in today's class we have seen what is the capacitance of parallel plate capacitor. What was the expression? C is equal to epsilon naught A by D for parallel plate, and for spherical capacitor this is the expression, right. So, in next class, tomorrow's class, we will talk about cylindrical capacitor and we will take up other arrangement also, so that we will understand how to apply formula, right. So, this is it for today's session. Hope you enjoyed class. Thanks for watching.